Some more on independent groups, still working with the first pen laptop study. Right, what about Cohen's d? Click down here and I get a panel for Cohen's d. Now Cohen's d is the effect size, so that's here the difference between the two means, about 5.7, divided by an appropriate standardizer. And for the independent groups, we use almost always the pooled standard deviation as the standardizer. That's the reasonable standard deviation to use as our unit for Cohen's d. So we'll expect it to be about 5.7 divided by 6.0, a little less than 1, and it is. Here we are, 0.94. Now, Cohen's d calculated like this is a little biased, and so we apply the unbiasing formula and find that d unbiased is about 0.93, just a whisker smaller. The larger the number of degrees of freedom, the smaller the bias, and so once we're up to about 63, it hardly makes any difference. So we've got an effect size of around about 0.9, and that is really a very large effect in most situations, and we'd probably judge it to be really quite a large effect here. We'd like a confidence interval on that d value, of course, so we have to click here to calculate it, and Esky goes off and does a bit of iterative calculation, which takes half a second or so, and here's the answer. So our confidence interval for delta, that's our confidence interval, our interval estimate of the standardized effect size in the population, is from about 4 to about 1.4. Or in other words, it's about d is about 0.9 plus or minus 0.5. So quite a wide confidence interval, as we'd expect, corresponding to this fairly long confidence interval here, but quite distant from 0. In fact, yes, of course, we'd have a p-value which is totally tiny because this confidence interval is so far from 0. Same with the confidence interval for delta. A long confidence interval in the population, the standardized effect size may be as small as about 0.4 or as large as about 1.4, but our best estimate, our point estimate, is round about 0.9. Next, I'll switch to the Summary 2 page, which is actually data for the Pen Laptop 2 study, and this page allows us to analyse data when we have just the sample sizes, means and standard deviations, the summary statistics for a study, rather than the full data. So we just type those values in here and we can see the mean and confidence interval for each group. We can turn on the figure with the difference axis and see the difference and the confidence interval on the difference, and we can turn on Cohen's d and click to calculate the confidence interval on Cohen's d. And in this second Pen Laptop study, clearly there's a very big effect, Cohen's d round about 1, and we've got a difference of about 5 percentage points, roughly similar to the first, and sample sizes are larger, so we've got a somewhat shorter confidence interval on our difference there. The p-value, of course, here is totally tiny, and the t-value going along with that is very large, and that's what you need for an independent groups t-test if you wanted to do that. But as usual, knowing the effect size and the confidence interval gives us the full, complete information for making our conclusions, and the p-value adds nothing more. Now back to data 2, I'm going to copy in the data to do exercise 3 of the ended chapter exercises in chapter 7. So first I'll clear the data here, clear all data, go to the file for these end of chapter exercises. I'm going to look at babies born, collect the low data and copy, and come back to here, right click for paste values, and go back to the file for the high anchor data. Copy back to ASCII and paste values. There they are. And I can type in here low and here high. And I can type in names and units and so on. And then I'm away and I can analyze these data. I've got an effect size of 1.1 and a confidence interval that's from 0.6 to 1.6, and then I can interpret as usual this difference and the confidence interval on the difference.